Mhm. This is the book which you are following. Sorry, Anya. Is this the book, The Chemical Change and the Reaction? Anya, if her mom is there, can I talk to her? Hi, Nidhi. नमस्ते, हरे कृष्णा। आप म्यूट पे हो क्या? हाँ, ओके। निधि, ऐसा हम कर सकते हैं कि हम लोग अब आज का क्लास यहाँ पे ही खत्म कर देते हैं। लेट अस डू इट टुमारो, ठीक है? एंड थोड़ा इस टाइम का रखिए ताकि उसका खाना भी डिस्टर्ब नहीं हो। इतने टाइम के बाद बच्ची घर पे आई है और फिर अगर हम यही करेंगे ना तो देयर इज नो पॉइंट कमिंग एट होम एंड स्टेइंग इन द हॉस्टल।
ऐसे मैंने खिला दिया, कोई बात नहीं, ठीक है। आप बताओ, आपको जैसे कंफर्टेबल आप बताओ।
मुझे कंफर्टेबल, बट देन आई नेवर लाइक दिस कि भाई है ना, बच्चा एकदम पढ़ रहा और खा रहा नहीं। हम एक ब्रेक ले सकते हैं, तो क्योंकि एक ऐसा माहौल रखो कि कन्वीनियंटली वो पढ़े। उसको ये भी ना हो कि भाई इतना सारा बर्डन स्कूल से पढ़ के आ रहे हैं, फिर घर पे भी आके हमको यही करना पड़ रहा है।
10 मिनट का अगर ब्रेक होगा ना तो ये खा लेती। एक्चुअली 10 ये बोली तो मैंने बोला 5 मिनट बोली तो बोली मैं ही खिला देती हूँ।
नहीं तो हम एक वैसा कर लेते हैं कि हम लोग नेक्स्ट टाइम क्या करेंगे, एक 10 मिनट्स 15 मिनट्स का ब्रेक
10 मिनट वो खा लेती है, उसको हो जाता है
आराम से। 15 मिनट्स तो खा ले आराम से। चलो 15 मिनट्स का तो पहले 2 सब्जेक्ट करके 15 मिनट का ब्रेक लेके फिर हम नेक्स्ट सब्जेक्ट कर लेंगे। हाँ,
तो खा ली।
हो गया पक्का?
हाँ हाँ पक्का।
क्योंकि ऐसा ना हो कि
नहीं नहीं नहीं, मैंने नहीं, वो बोली 5 मिनट्स तो मैंने खिलाया, तो 10 मिनट्स में हो जाता है उसका।
and anytime you can tell me, Anya, that I want a lunch break or whatever. It's okay. आप घर पे हो बेटा। हमारा रिलेशन है ना एज अ टीचर और स्टूडेंट वाला नहीं है। बरखा बुआ है ना, बरखा बुआ, वो मेरी फास्ट फ्रेंड है, ठीक है? तो हम लोग का ऐसा हार्ड एंड फास्ट वो टीचर और वो वैसा रिलेशन नहीं रहेगा। आप आराम से मुझे बोल सकते हो एकदम फ्रीली, कोई दिक्कत नहीं है। चलो, ओके। So should we continue, Nidhi?
Yes.
How is that? Anya, should we continue?
Yes.
Okay. So this is the book you are following, right? Chemical Change, Chemical Reaction. Is this the same book, Anya?
No, it is concise chemistry.
Yeah, this is also concise chemistry.
हम लोग कैरेक्टरिस्टिक्स भी है पहले, इधर नहीं है।
अच्छा, इससे पहले कैरेक्टरिस्टिक्स भी है आपको?
और सब सेम।
ओके। This one, the characteristic of chemical reaction, evolution of gas. ये वाला ना? Change of color, formation of precipitate, change in state. Is this concise, Selena?
Yes.
Okay. So, chemical reaction. So, chemical reaction, it's a process of breaking the existing bonds and reacting the substances and making the new bonds. For example, हमारे पास sulfur dioxide है and water है. हमने उसको react किया. So first, what will happen? The bonds of water will break and it will react with sulfur dioxide and new bonds will be formed and we get sulfuric acid. Okay, so chemical reaction is a process in which the old bonds are broken, reaction takes place and new bonds are formed. Okay, so क्या हो रहा है? तीन process हो रहा है. Number one, the old bonds break, the reaction takes place, and then the new bonds are formed. So chemical bond, what is chemical bond? So chemical bond is the force that holds the atoms of molecules together as a compound. Water, so hydrogen and oxygen molecules are held together by a force, and that force is called chemical bond. So the chemical changes or the chemical reaction, how do they take place? So there are various necessities which we have to take care. कि अगर हमने एक solid sulfur लिया और हमने solid iron लिया, so if I keep solid sulfur with the solid iron, they will not react. They will not react. So the first thing is that there should be a close contact. So the components which are reacting, the elements or the compounds which are reacting, they should be in close contact. So when they are in close contact, that means it is possible that they should be either in powdered form. If they are solid, so they should be in powdered form. And if they are liquid, then they should be in, then there is no problem, they are in contact. So chemical reaction occurs when two substances are mixed in their solid state or in solution state. So when they are in solid state, then they are powdered, so that there is a close contact. For example, you see here, we have lead nitrate with potassium iodide. So they are both solid, so we take the powdered form and then we react and we get potassium nitrate and lead iodide. Now the next one, that is the solution. So in solution, it is easy. Just say sodium chloride liye, aqueous sodium chloride and aqueous, we have silver nitrate. So then easily they are in contact and so the chemical reaction will take place. So the first condition necessary, so these are the conditions needed. So the first condition that is necessary is the close contact. So if If the substances are in solid, they should be in powdered form. And if they are liquid, then they easily are in close contact. Then the second one, the heat. Some chemical reactions occur when heating is required. So by heating, the reactions take place. So copper carbonate. So when copper carbonate is heated, it forms copper oxide and carbon dioxide. This is a decomposition reaction, which we are going to learn further. So copper carbonate on heating. So that heating is required. The reaction is carried forward by heating. So the condition required is heating here. Similarly, lead nitrate on heating decomposes. So again, this is a decomposition reaction. So that forms lead oxide plus nitrogen dioxide plus oxygen. Then we have, in some reactions, the light is necessary condition. So carbon dioxide reacts with water in presence of chlorophyll and light, sunlight, which is photo, to form photosynthesis, and that is sugar and oxygen. So here we have 6 CO2 plus 6 H2O gives 6, which gives C6H12O6 plus 6 O2. Then hydrogen and chlorine in presence of bright sunlight is explosive reaction. But in presence of diffuse sunlight, it takes place mildly. So that again, sunlight is required. Similarly, chlorine reacts with water when exposed to sunlight. So it forms hydrochloric acid and oxygen. Do you have all these things? I think this is towards the end of the chapter. Just check.
Yes, I have.
Okay. So these are the conditions. So the solution of silver nitrate and hydrogen peroxide, when they are kept in brown bottles in the laboratory, because they decompose in presence of sunlight. So that is why they are kept in brown bottles. This is very important. You have to mark it there, give reason why silver nitrate and hydrogen peroxide are kept in dark brown bottles. So because they decompose in presence of sunlight. They decompose in presence of sunlight. Silver nitrate in presence of sunlight decomposes to form silver and nitrogen dioxide and oxygen. Okay, and I will be giving you, the color changes also. So you have to write it in your book at there itself. Okay. Just a minute. Okay. So here, in the first one, mixing or the close contact. So you should write here 2 substances are mixed in the solid state in powdered form. Okay. And then here in this, under the heat reaction, this we have copper carbonate solid. So write here green copper carbonate. Below this you write green. And below copper oxide write black. Okay. So the green copper carbonate converts black residue, copper oxide, black copper oxide. Then the next one, lead nitrate. This is white. And it turns into yellow, buff yellow, BUFF, buff yellow. And this PBO is known as litharge. The other name for PBO is litharge, LITHARG, litharge. Okay, then we come back to this silver nitrate. So the silver nitrate, here below the silver, you write shiny. No, you write, yeah, shiny silver metal. Okay. Now, there are some reactions which take place only when the current is passed through it. Current electricity is passed. So they are called reactions or electrolytic reaction. So electrolysis of acid-related water, it takes place only when the current electricity is passed through it. So current electricity is the condition over here. So we have two reactions, that water decomposes to hydrogen and oxygen, and sodium chloride decomposes to sodium and chlorine. So these are all examples of decomposition reaction. Then the next one, some reactions take place under the pressure. Some reactions take place when there is a pressure. So mercury chloride and silver potassium iodide rubbed in a mortar. So when they are pressed, then the scarlet color substance mercury iodide is formed. This is red mercury iodide. Whereas nitrogen combines with hydrogen under high pressure to form ammonia. So here, acts as a catalyst. And this reaction is a very important reaction. We are going to study this reaction in so many places. And this process is known as Haber's process, which I'll tell you later. Now, catalyst, some reactions in presence of a catalyst. Now, what is a catalyst? So catalyst is a substance which accelerates, which alters. Don't write accelerate or decelerate right there, which alters the rate of reaction. Catalysts are substances which alter the rate of reaction without taking part in the reaction. Please note it down. Catalysts are substances which alter the rate of chemical reactions without.
Catalysts are substances
which alter the rate of reactions, rate of chemical reaction,
which alter the rate
without taking part in them. So catalysts are substances which alter chemical reactions without taking part in them. Okay, so here we have an example, like we have this potassium chlorate. So potassium chlorate decomposes to potassium chloride and oxygen. But if I add manganese dioxide here, If I add manganese dioxide, the reaction is fast. And so manganese dioxide acts as a positive catalyst. There are two types of catalysts. Positive catalysts speed up the reactions and negative catalysts slow down the reaction. Positive catalysts speed up the reaction and negative catalysts slow down the reaction. Okay. Positive catalysts speed up the reaction, negative catalysts slow down the reaction. And there is another this reaction. This is the catalytic oxidation of ammonia. This is oxidation of ammonia in presence of platinum as the catalyst. So this is called catalytic oxidation of ammonia. And in this reaction, the platinum acts as a positive catalyst. Clear? So 4NH3 plus 5O2 gives in presence of platinum at 800 degrees Celsius, give 4NO plus 6O2, 6H2O. So that is the positive catalyst again. So when the catalyst accelerates the reaction, it is known as positive catalyst. And then when the catalyst decelerates the reaction, then it is called negative catalyst. This hydrogen peroxide in presence of manganese dioxide accelerates, manganese dioxide is accelerating. And so this is a positive catalyst once again. Then substances that influence the rate of chemical reaction. Now, the substances which increase the efficiency of the catalyst are called promoters. So promoters are substances which improve the efficiency of a catalyst. For example, this, I told you this reaction, this is Haber's process. In Haber's process, this molybdenum, okay, this molybdenum acts as a catalyst. Acts as a promoter. Iron is the catalyst. So here iron is catalyst and molybdenum is the promoter. Okay. Then we have negative catalyst, which slows down a chemical reaction or retards a chemical reaction. So phosphoric acid, it retards the decomposition of hydrogen peroxide. Then the oxidation of chloroform decreases in presence of alcohol. Okay. Then there are certain chemical reactions which proceed by the absorption of sound energy. So acetylene breaks up into carbon and hydrogen by absorbing sound energy. So these are few conditions which are required for a chemical reaction. So let us quickly go through them once again. So what are the conditions required? Number one, the close contact. So solid should be powdered, and liquids, then they get close contact any which ways. Then the next one is the heat. And then some reactions take place only in the solution form. So that is liquid form. Then the heat is necessary in some reactions, light is necessary in some reactions, electricity is necessary in some reactions, pressure is required in some reactions. We use catalyst, which can be positive or negative, and in some reaction we have sound energy. So these are the conditions required. The characteristic of a chemical reaction. Now, what are the characteristics of chemical reaction? Now, chemical reaction is accompanied, sometimes is accompanied by the evolution of gas. In some places, there is a change in color. In some places, precipitates are formed. In some places, change in state takes place. So these are the four characteristics. Number one, that is the evolution of gas. Now, whenever an active metal. Now, what is active metal? Those metals which are above hydrogen in reactivity series. Have you done reactivity series in class 8?
Yes, class 9 also we did.
Okay, so those metals which are above hydrogen in the reactivity series are called active metals. So when active metals react with dilute acids, they always liberate hydrogen. So the first reaction you see, zinc combines with sulfuric acid to form sodium zinc sulfate plus hydrogen. So this zinc is the active metal, dilute sulfuric acid, and the products form zinc sulfate and hydrogen, so gas is liberated. Now, some reactions, so whenever there is a gas liberated, sometimes the gas bubbles, they come out in, the bubbles are formed, and that is called effervescence. Effervescence. So effervescence is a phenomenon in which the gas comes out in the bubble form. It is possible only when one of the reactants is liquid. Then effervescence takes place. Okay. Then there are sometimes the change of the color, as I had told you earlier, that green copper carbonate, when decomposed, forms black residue. So there is a change in color. Similarly, here when iron reacts with copper sulfate solution, this iron is blackish in color, but we have blue solution, copper sulfate. Now, we were talking about the change in color. So there are certain chemical reactions which are characterized by the change in color. As I had told you earlier, green copper carbonate decomposes in presence of heat to form black residue, correct? So there is a change in color. Similarly, when iron filings are dropped in copper sulfate solution, so the blue copper sulfate solution, the blue solution changes to green. So that is the change in color. Blue solution changes to green and red deposition is observed. So sometimes they ask you, what do you observe? What do you observe when iron filings are dropped into copper sulfate solution? So we have two observations here. Number one, blue solution changes to green solution. Number two, red deposition is seen. Red deposition is seen. Okay, when we write the observation, we do not write the compound's name or element's name. We do not write. Mark this. This is very important. So whenever the observation is asked, you do not have to write the inference. You have to just mention the observation, change in color, or the gas is evolved, whatever. You don't have to mention the compounds. Now, formation of precipitate. Certain chemical reactions are characterized by the formation of insoluble solid substance called precipitate. Insoluble solid substance called precipitate. So when a solution of silver nitrate is added to sodium chloride, so silver nitrate solution added to sodium chloride, both are colorless. Both are colorless, but you get a white precipitate. You get a white precipitate of silver chloride. White precipitate of silver chloride. Okay, so this is the formation of precipitate. Similarly, when Ferrous sulfate. Ferrous sulfate, again, this is green. Huh? Ferrous sulfate is green. So ferrous sulfate is when sodium hydroxide is added to ferrous sulfate, we get dirty green precipitate. We get a dirty green precipitate of ferrous hydroxide. So that is a precipitation reaction. So in some cases, we get gas. So evolution of gas takes place. And if one of the reactant is liquid, then we have the effervescence, that is the bubbles coming out. Then in some cases, we have the change in color. So as we have seen, blue copper sulfate solution changes to green ferrous sulfate solution. But when we are writing the observation, we will not mention the compound. Then we have seen that the formation of precipitate when two liquids combine. You get a solid and a liquid, and that solid is called precipitate. Two soluble liquids, when they combine to give out one insoluble substance, that insoluble substance is called precipitate. So when silver nitrate reacts with sodium chloride solution, you get a curdy white precipitate. It's not just white. Please write the curdy white, C-U-R-D-Y. We get a curdy white precipitate.
Okay.
Clear?
Yes.
Then ferrous sulfate. So green ferrous sulfate. This ferrous sulfate is green. So, but it forms a dirty green. This is solution, but we get a dirty green precipitate. Dirty green precipitate. Okay. Then in some cases, there is a change in state. Now, ammonia is gas, combines with hydrogen chloride gas. So two gases are combining to form a solid, that is ammonium chloride. So two gases combine to form a solid. So change in state is happening. Okay. Now let us quickly go through this exercise. So what is a chemical reaction? So how do we write a chemical reaction? Chemical reaction is a chemical change. It's a chemical change where old bonds are broken, then new bonds are formed. Old bonds are broken and new bonds are formed. State the conditions necessary for a chemical reaction or change. There are various conditions we had studied. Number one, close contact. Number two, solution.
Heat,
yes.
Light, electricity, pressure, catalyst.
Very nice. Then define the following terms. Chemical bond, it is given there. You can mark it in your book. Effervescence and precipitate, all are given. Then give an example of a reaction where the followings are involved. So you have all the reactions in your book.
Yes.
Please learn them. Then define a photochemical reaction, a reaction in which
light is necessary.
Sunlight is required. Yeah, photon. And in which electricity is required.
Electricity is required.
Yes. Give an example of each of the following chemical change. So a photochemical reaction involving silver salt. So we had seen that silver chloride or silver nitrate, है ना? Silver nitrate is kept in dark bottle because it decomposes to form silver, nitrogen dioxide, and oxygen. Then involving water, which reaction we had seen with water? A photochemical reaction, carbon dioxide combines with water.
Hydrochloride, HCl.
HCl wala, acha, yeah. Chlorine, yes. With to form sodium hydrochloride. HClO wala to nahi, chlorine reacts with water to form HClO. Yes, but usse acha reaction है photochemical wala, photosynthesis wala reaction. That is very good reaction. Okay. A reaction involving a blue solution. Blue solution किसका होता है?
Copper sulfate.
Very good. A reaction formation of dirty green precipitate. किसका है ये?
वो
ferrous hydroxide.
Formation of precipitate.
Formation of precipitate of ferrous hydroxide. With two gases, ammonia and hydrogen chloride, forms a solid. Then a reaction where color change is noticed, that we have seen so many times, right? Green copper carbonate, black residue. Then a chemical reaction where the following are observed. So gas is evolved, chemical change is noticed, precipitate is formed. All these we have done. Give the reason for the following. Now this is important. Silver nitrate solutions are kept in colored bottles because silver nitrate decomposes in presence of sunlight. And you give the reaction.
Because silver nitrate
in presence of decomposes in presence of sunlight. And then you can give the reaction. Then molybdenum is used in the manufacture of ammonia because molybdenum acts as a promoter to iron, which is a catalyst. Then blue solution of copper sulfate changes to green when a piece of iron is added. This is because of the displacement reaction. Iron displaces copper. Iron displaces copper from copper sulfate.
Colorless concentration sulfuric acid in the test tube, color changes to blue on adding a small piece of copper.
No. We are talking about the blue copper sulfate. That is the displacement reaction. We had seen that this one change of the color. Mein iron when added to blue solution forms green solution and copper deposit. Color change. So here you see this iron displaces copper. It is a displacement reaction. Okay. So with this, we finish the part A. So tomorrow we'll be doing the part B. So we stop here.